All right, we are finishing off that last problem on our exponential model notes, and I lost my red pen, so we are just going to finish it out in purple. You do still need a calculator. Our final problem today is looking at student loans. So one particular bank offers a student loan with an interest rate of 2.75%, and that is compounded annually, which means once a year. So if you take out an $8,000 loan from this bank, interest rate starts accruing right after the bank issues the money. So before I even read further, I'm going to go ahead and write the function that represents this interest. So this is the compound interest formula. Remember, P is your principal, R is your interest rate as a decimal, N is the number of times it's compounded a year, and T is years. So in this scenario, I'm borrowing $8,000. 1 is just 1. My interest rate is 0.0275. I'm compounding once a year, and that's going to be to the 1t power. Now, to make things a little bit simple, anything divided by 1 is just itself. So this is really 1 plus 0.0275. So I can make my life ever so slightly easier. And again, 1 times t is just to the t power. So this looks very similar to our standard exponential model, and when we are compounding just once a year, we can use that to represent it accurately as well. So how much interest will have accrued on your loan after 4 years of college? Well, that means t equals 4. So if I plug that into my function and round to the nearest cent, because we're talking about money, 8,000 times 1.0275 to the 4th power. That's about $8,916.97, and that is my total balance. That is the principal amount I borrowed, excuse me, plus the amount of interest I owe. So if I want to look at just how much interest will have accrued, I have to subtract the initial amount that I borrowed, and the amount of interest that I owe is $916.97. So your friend says that since you expected to be in college for 4 years and you're charged 2.75 interest every year, the total you owe after 4 years is an 11% increase of the original amount you borrowed. So their thought process is you've got 2.75% interest over 4 years, and 2.75 times 4 is 11. So let's evaluate if they are correct. So they're saying I owe 11% more than I borrowed, an 11% increase. Well, we know that the increase we had is this interest amount. So what I need to verify is this 11% of the initial amount I borrowed, 8,000? Well, I can calculate 11% of 8,000. I can multiply 8,000 by 0.11, because 11% as a decimal is 0.11. And if I do that, I get $880, which is not equivalent. So your friend is not correct, but let's figure out what percent we actually have. So I'm going to take that interest amount and divide it by my principal. And when I do that, I get 0.114, because it's still a decimal. I get 0.115, which as a decimal is about 11.5%. So it is close to 11%. However, we can clearly see that there's about a $40 difference, and the bank isn't going to go, oh, don't worry about those $40, you're close enough, right? That 0.5% makes a difference. And then to close it out, we're going to compare a different loan in a different bank. So let's say that it only has a 2% interest rate, but it compounds every 6 months. So what would we, which would result in us owing less money? Well, this formula would be my same principal amount times 1 plus, my interest rate now is 0.02 over, if I'm compounding every 6 months, that's twice a year, and that would be to the 2t power. And then to make my life a little bit easier, I'm going to just simplify this inside. 0.02 divided by 2 is 0.01. If I add that to 1, that becomes 8,000 times 1.01 to the 2t power. So after 4 years, I can say 8,000 times 1.01 to the 8th power, and if I round that to my nearest cent, I have about $8,662.85. which is less than the first loan would have given me. So even though this one is compounding more often, that lower interest rate is making a large difference. All right, that wraps up our notes today. Thanks for coming back for part 2.